Assalamualaikum. My name is Muhammad Hussein Muhammad dia. My matrix number DE170022. So I will present about our projects that have titles using a dynamic voltage restorer to mitigate voltage sag in a grid connected PV. So for the introduction parts, firstly for the project backgrounds, in a definition of IEE, power quality is the concept of powering and grounding sensitive equipment in a manner that is stable to operation of that equipment. But in the Tenaga Nasional Berhad TNB, power quality or others voltage quality refers to the changing of the perfect sinusoidal voltage waveform to non-sinusoidal or distorted voltage waveform. For the problem statements, firstly, we need to know power quality have three major categories, which are voltage, frequency, and also waveform. So, what is power quality is proficiency of electrical equipment to consume energy that supplied to it. The quality and continuity of the power supply is very important for the efficient functioning of the end user equipment. So nowadays, a lot of amount electricity generated from renewable resources that give impact of global warming. So we need to reduce this global warming and maintain the power quality in the system. For the objective part, firstly, this project is to study about the power quality problems and their effect of power quality in PV technologies. Then the second point is to give skills about using MATLAB software and shows the voltage sag. The third one is to explain the relationship between PV technologies with the PQ problems. And lastly, to suggest the sustainability techniques used for the mitigation process. So for the scope of this project involves simulation in MATLAB software. From the MATLAB, we can produce a model and electrical schematic. Then we can simulate a power quality problem caused by over voltage tangent through surge arrestor. Then the simulation focusing on the voltage and current waveform at parallel connected arrestor. Then we go to the second chapter, that is a literature review. For the first one is voltage sags. In a definition of IEE, voltage sag is a reduction in voltage for a short time. The voltage reduction magnitude is between 10% and 90% of the normal root mean squared, or known as RMS voltage at 60 Hz. So the duration of voltage sag event is less than 1 minute and more than 8 milliseconds, or a half cycle of 60 Hz electrical power. So when the voltage sags that occur on the utility side of the power meter can either be human created or natural events. So the second one is a voltage swell. Voltage swell is a transient voltage that is temporarily unwanted voltage in an electrical circuit that range from a few volts to several thousand volts and then lasts microseconds up to few milliseconds. So the transient voltage can be caused by sudden release of stored energy due to incidents such as lightning strikes, unfiltered electrical equipment, contact bounce, and arcing. But faulty contactors and lightnings are the most common problems in this voltage swell. So the last one is a transient voltage. It's known as harmonics, unwanted higher frequency which superimpose on the fundamental waveform, creating a distorted wave pattern. So in a AC circuit, a resistance behaves in exactly the same way as it does in a DC circuits. So that is the current flowing through the resistance is proportionally to the voltage across it. And the last one is harmonics are voltage or currents that operate at a frequency that as an integer problem integer multiple of the fundamental frequency.
Okay, for my part, I will discuss about methodology. So, in order to meet the objective of this paper, there are two important methods to be considered. Firstly, we need to study and understand the literature review that related with the research. So, literature review is based on the entire component in the energy store system and power quality issue. The second one is to study the familiarize with simulating MATLAB simulating software. So, in the literature review also cover the simulation review. Uh, and based on the scope of this paper, the simulation was test on distributions on the distribution system, which consists of two feeder and balance load. So, in order to investigate this service event, three line to ground fault was generated. Then automatically voltage surge will occur. The effect of using DVR and study the mitigation of voltage surge we show in the result and discussion. So we move to the flowchart. So this is the flowchart. This is the flowchart basic concept of DVR operation. One of the most accurate and efficiency custom power device in the power system is dynamic voltage restore. This apa, that's mean DVR. These device are used to protect sensitive load in the industry from being tripped as well as from voltage swell and other system fault. DVR compensate for both voltage surge and swell. The condition is that in the grid supply must not completely shut down. So this is the block diagram. So from the block diagram, we can come out with the operation of DBR. So the operation of DBR is controlled by the control circuit, which is compensate for voltage surge in solar PV system. That our system in this project. So the control circuit, which is a PI controller, will compare the load voltage to the reference voltage uh, to monitor it if it voltage surge occur on the distribution side. The difference between the reference and the load voltage will cause any error signal to be generated. So the value of VSI through the PWM control unit, which can be seen in the circuit after the error is minimized by the PI controller. So the inverter will be triggered by a PWM generator, which will produce the desired magnitude, phase, and frequency. Uh, in uh, in order to inject the missing voltage at the transmission line. So that's all from me. Thank you.
Okay, for my part, I will discuss about the result of the simulation. For that, my name is Muhammad Hairul Aiman, JNE AE170063. Okay, let's go to the simulation. Okay, this is the grid that we designed with the load side before the voltage is applied to the solar PV system. Okay, the script is designed to a normal condition where no fault and error is occurred. So this is the three-phase supply in transmissioner with the voltage supply with 11 kilovolt at 50 hertz connect to the three-phase transformer 1 megawatt and 50 hertz. This impedance of resistor and inductive transmit to load. Okay, let's go. We will try run this. Okay, as you can see, this is the result of the simulation. You can see the V input is the signal of V input is same with the voltage of the output at the load. So this means is no fault occurs at all. Okay, we will continue with the second condition. We say we add fault at the diagram, which is the DLG fault. The DLG fault means by double line to ground fault, which is occur when any two phase of the power circuit is short circuit to the ground or the neutral. So we add the transmission line to simulate the voltage set. So the resistance set is to 0.04 ohm. So we will run the simulation. So this is the result of the simulation. As we can see, during the initial power is applied to the voltage, the signal become drastically drop to the 98.97 volt at 0.03 and to the 0.08. It occurs between this time. Okay, we will continue with the last part, which is with the mitigation method condition. Uh, and during this condition, the three-phase circuit breaker and dynamic voltage restorer (DVG, DVR, DVR) are add into the circuit. So the three-phase breaker will add between the bus bar 1 and bus 2. So and the voltage we measure at the load. So we will run the simulation to see the result. Okay, so this is the result of the voltage waveform at the mitigation part, which is the simulation of the result can be done during the mode of the DVR operation less than zeros. So since this is the mitigation part where we apply the DVR, the phone seem to be at the 0.03 to the 0.08. But when we add the DVR, it can be seen from the result, the DVR can compensate the voltage set by inject the right amount of the voltage reduction when the set occur at the supply side. So the voltage reduced to 200 and 100 volt, and the injection by the DVR is 100 and 200 volt to regulate the load voltage, which is prove the reliability of the DVR in monitoring and minimize the voltage set. So the voltage shall continue back to the normal condition. That's all from the simulation part.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ilman Arabi Ibrahim. And this number D170066. So today I would like to present about the conclusion from our group project. So as a conclusion, this power quality issue one tokenomics are avoidable to reduce the using a technique that has been discussed. There is no one mitigate technique that will be stable with every application. And with the power supplies, the strive to supply the improve power quality. In addition, we are going to present the application of power quality issue more meaningful, more detailed, understandable, and easy to express in visualization concept. The best way to avoid power quality problem is to ensure that all equipment to be installed using solar PV are compatible with power quality in the power system. Therefore, repair water set to the solar PV are one of the important things that can damage the whole system in term of power quality. So we're using a technique for mitigate the power quality, which is water set using DVR, which is dynamic water restore. So in this study, modeling and simulation of DVR is controlled by VI SVW using mallet simulation. The simulation has shown that DVR can compensate the set quickly from 0.03 to 0.08, which is the voltage set be involved there. So from there, we using a circuit of DVR to make sure the signal of voltage set can be reduced, which is between 0.03 until 0.08. So the controller show a good performance be addressed and enhance the output voltage. From the simulation, it's clear that show the improvement of these two factors and how they affect the performance of DVR. Therefore, when it comes to implementation, it's crucial to consider in this factor so that the performance of the VR can optimize fully. So I think that's all from us. Thank you.